Welcome to Mastering Solutions. In this problem, they tell us that we're 165 centimeters tall, and I'm so used to putting everything in meters for SI units that it feels weird to leave it in centimeters. For this question, you can actually leave it in centimeters since all the units are the same, but I'm going to put it in standard units just because it's safe if you do that. And so that's going to be 1.65 meters. And they tell us that we're standing 200 centimeters in front of a plane mirror. Okay, so we'll say that is 200 centimeters or 2 meters. And they ask in the question, how far is it from our eyes to the image of our toes? So for this, it's really helpful if we draw out the picture completely. If we are looking at our toes, what it appears to us as is if we're looking down at our toes like that. You remember from the book that the object distance with a plane mirror, so not a convex or a concave mirror, we know that S, or the object distance, is equal to the image distance. And so this distance here is also 200 centimeters or another 2 meters. What's actually happening though is we're looking in the mirror and the light is being reflected, so we see the image of our toes like this. And so this is the angle of incidence, and then we have the angle of reflection right here. And so if you look at it, as we've done so many times in the previous chapters in this book, we just created a giant triangle, right? So here's our triangle there. So if we redraw the triangle, this is our right triangle here. This is the 1.65 meters. And then this whole leg is 2 and 2 meters or 4 meters total. And so we need to figure out what is the distance from our eyes to our toes. And so you could try to figure out what the angle is here and calculate this path distance. So we'll say this is D for distance, right? And this would also be the exact same here, D for distance. But like we already figured out, the path length is the exact same if we figure out this whole distance here. And so this is what we're trying to figure out, which is essentially 2D. And now we don't need to solve for what D is because this whole distance is what we're trying to find, the distance from our eyes to our toes. So you could just leave this as X if you wanted. I'll keep it as the 2D so it's just not confusing that we have the 2Ds here. But if we look at it as we've done so many times in the past, we can use trigonometry. So we have the short leg and the longer leg, and we need to find the hypotenuse. So we can use the Pythagorean's theorem. And that says that a squared plus b squared is equal to c squared. We're trying to solve for c. So c, of course, is equal to the square root of a squared plus b squared. And so now when we plug this in, we have c, or I'll keep it consistent here, 2D is equal to the square root of 4 meters squared plus the square root of 1.65 meters squared. And so 2D is equal to the square root of 4 squared plus 1.65 squared. And so that gives us 4.32, and we can round that to 4.33. So the total distance from our eyes to our toes is 4.33 meters or 433 centimeters. So that's our answer for this question. The distance from our eyes to our toes is this right here, 433 centimeters.